And welcome you all to another and our final, well, final for me seeing you unless I see you in the hallways, a marvelous Monday. I don't normally wear white shirts, but I found my old Marvel white one. And I was like, yeah, I'm gonna wear that today. So I'm feeling pretty excited, exciting day. Yes. Can what? No, yeah, I don't think so. You email me about it, I'll take it into consideration. All right, okay. You never know. You can have colors of the, yeah. I mean, Adam actually, he has yellow shirt Tuesday. Yeah, I was like, where did that come from? He said, just some guy had a yellow shirt he'd always wear on Tuesday, so we all started wearing yellow shirts on Tuesday. But you know, it is what it is. All right, so just an announcement for tomorrow on campus. We've got the PAC, right? You guys know what PAC advisors are? Professional Advisory Committee. They come every 6 months and kind of take a look at the curriculum, take a look at future changes to courses and things to make sure that we are in line with what the industry is doing. So we've got people from, I mean, if you look, Dave Hackett, he actually writes RenderMan. So if you want to know about rendering, he's the one to talk to. So he comes in, he talks. He's the one that also said, hey, don't upgrade your operating system because RenderMan will not work. They said that OS, Mac OS, there's really making it more difficult for them to where they actually, you know, people like, not Autodesk, but Adobe were like, well, maybe we'll stop supporting Apple because they're making it harder for people to make things to run on their software. So kind of interesting, but he's real big tech head. And if you got questions about rendering, he's the one to go to, especially using RenderMan. We've got people from Sony. We've got, you know, people from EA. I think we have got Ricardo Arizia. I can't remember where he was at, but he's a really good character artist. He's here. But anyway, they come every 6 months. We've got them from all over the place, and we get about 6 or 7, possibly 8 at a time that'll show up, and they'll talk to the students and talk to us and everything like that. So they will be doing something for the students tomorrow at 10 a.m. in the Fortress. So it's basically Q&A. You have questions for them, show up, and you can ask questions and kind of hear the conversation. It's not something where you go, yeah, I don't want to go see that. I would definitely recommend anytime you have that opportunity, I would do it. So that is first come, first serve, 10 a.m. to the Fortress. And then after that, 1:30, they'll be doing the showcase, the demo reel showcase, which you all will be a part of when you get into those classes. You'll have stuff ready. I think it starts in port 5 and then 5, 6, and 7. You bring your stuff in and instructors will go in there. Other people will go in there and take a look at where you're at. But this one is cool because you've got the professional advisory committee in there looking at your stuff and giving feedback. So it'd be nice to kind of just listen to what they say. You know, what advice are they giving other people? You know, that helps you not make the same mistakes or make sure that you know that you're on track, things like that. So pretty cool, good opportunity. Again, if you haven't seen the Fortress, you get to go into the Fortress and do that Q&A. It'll be the first time they're doing it in the Fortress, so kind of interesting to see how that works out. But it's cool, and every 6 months they're here, and you can talk to them. So it's pretty neat. Yes.
When did you say it was again?
Tomorrow, 10 a.m. in the Fortress, and then at 1:30 is the demo reel showcase. Usually that's on a Thursday, the last Thursday of every month, but because they come Monday, Tuesday, they moved it to Tuesday. The portfolio students aren't happy about that, but yeah.
That's the same place?
Yeah, it's going to be in the, I think it's room 131, 130, 132. So that other side there. So it's pretty cool. Check it out. Talk shop, get your name out there, you know, because they might be people that are hiring when you go to certain companies. Yeah. I don't know if it was put under that. That's why they asked us all to, yeah. So yeah, just write down in your notes, Fortress tomorrow, 10 a.m. Be there or be square, right?
10 a.m. or 10 p.m.?
I mean, you can be there at 10 p.m. if you want, but 10 a.m. is when everyone else will be there. Yeah, 10 a.m. No, I'm just kidding. Yeah. Yeah, I mean, I kind of wish it would be a little later because then more people could show up because I think they seem to forget. Like today, right now, they're doing the staff Q&A, and I was talking to all of them, and they're like, "Oh yeah, you're gonna come see our talk?" And I was like, "No, I'll be lecturing." And I go, "You guys want to come into my lecture room and talk to my students?" They're like, "Yeah, we'd love to." And then the people that run the schedules were like, "No, we don't have time for it." So I tried to get them in here, get you guys some info, but no, it's really cool. Ricardo, I actually remember when he was a student. He was over in the other building. I was one of the lab instructors for final project, which is now your portfolio classes. And yeah, really cool. Always a hard worker. And you know, sometimes it's nice because they'll tell you the stuff that we tell you, but maybe coming from them means more. I don't know. But a lot of times, you know, they bring some good stuff to the table, trends and things that are going on in the industry. Tonight is your week 3 submission. So hopefully we're all geared up for that. I do want to look at and talk about, make sure that we've dotted our I's and crossed our T's. This would be a week 2 submission. Right, remember we've got skull structures. This was week 2, skull structures established, planes of the face established, all the parts and pieces of the outfit pretty much established, thicknesses figured out, line qualities figured out, structural elements in place. Week 3, minus the hair. If you want to block out the hair, that's fine, but that does not count towards the grade. So everything minus the hair. Now we've got wrinkles. We've got tighter anatomy. We've got full hands developed, fingers, right? Toes, if you can see them. We've got clothing details, facial details, all established and ready to go, right? We are only doing this on one character. And then for that one character, you've got the 2 props. Remember, there was a snafu, so I did say if you ran with how it was written in the beginning of the week, that was okay. It's still acceptable as long as it kind of makes sense. But this is where we're going from that to this. We should see visible change throughout the model, and every part of that model should update. Yes?
What if we decide to change props to like 2 posts for a character, put our breakdown and start?
That's fine.
That's fine?
That's fine. Yeah, because of the snafu, I'm pretty lenient with that. Yeah.
Okay.
The prop breakdown is something that is kind of just an exercise on how to look at bad reference and get yourself some more information kind of thing. So cool. That'll work. Okay, so we're clear where we need to be. Remember, dot your I's, cross your T's, look at your props, make sure that they are detailed and match your reference. I get a lot that are just, here's a sword and it's a 2-handed broadsword and they turn in a katana or something like that. It doesn't kill your grade, but you know, we might as well get the easy points, right? There's points out there, they're easy points to get. I want to grab all those as I can and keep things going. Okay, so make sure your props are up to speed, looking good, and we go from there. Yes?
Okay, so we're not going to incorporate these props into a scene?
If it's something they're wearing, like some people did holsters, some people did guns in the holsters. You can, when you're submitting like this, the character, right, the prop would be there, but you're also going to highlight the prop like these. This is basically, this is what, let me zoom out here. This is what the template looks like, minus the naming information, but you've got the reference and then your prop highlighted. Same thing here, reference, prop highlighted. Okay, so they will be on their own so I can grade them as such. Okay, so there'll be basically three images, 3 PDF pages being submitted. Yes?
If they have a mask, should we put it to the side?
That is recommended, yes. Yeah, because I need to see that face. Okay, any other questions for submission? You know, I know you guys are super excited. You're like, I can't wait. Get that stuff in. All right, that's the enthusiasm I like to hear. I like the cat shirt back there, real nice. Wear it on Thursday though. Thursday.
But he's got Wolverine clothes.
Oh, touche. Because I have one that's got Deadpool and he's riding a unicorn cat, so I can double that one too. I like your style. Very nice. Very nice. I didn't see the Wolverine claws. I love it. Awesome. All right. Cool. So any other questions about week 2 or week 3? Sorry, we'll jump into week 4. One of my favorite topics, topology. Okay. I love topology. I think it's just super fun. It brings back that technical aspect of modeling that miss. Oh, interesting. So whenever you got people working, it's kind of cool to understand what they do, because you walk out under Full Sail's guidelines, right? And you're like, okay, well, I know this software, I know this, I know that. They said this, they said that, so on and so forth. But when you get to a job and then you go, well, this is completely different. So why I'm bringing this up is, some cases, certain things are allowed, in some cases they're not. So Adam was talking to Christian, who was a PRM, he was a PRM lab instructor, and we shared him in CMF. And he got hired up at a company working on Paw Patrol animated series up in, I think he's in Toronto. Yeah. So, and the first interesting news was, right, that they're working on, I think we talked about it, they're not working on the latest and greatest Maya, they're working on Maya 2014. They are working on the latest ZBrush, and 0 tries allowed on any of their models. No triangles allowed whatsoever. That's just their pipeline, that's their workflow. There's got to be a reason for it. But yeah, they don't allow any. It's all quads all the way through. So when you hear that and somebody goes, well, that's bullshit. Sorry. That's bull poopy. We can't, oh no, I was talking to so and so over here, and they said they use tries all the time. Yeah, that might be so, right? There's one thing you have to understand, and this comes back to a story that came from the PAC advisors. They said, you know what we're having a hard time getting? People that just do what we ask them to do. We say we want this, they give us this plus their own ideas and something else. I just need this part of this puzzle. It goes somewhere else. They don't know where it goes. Just give me that. That's what we asked for. It goes from it. I'm not talking about Full Sail students. I'm talking about all new employees that they were getting. They were just like, man, it just seems so hard to get people to do what we ask them to do. They always want to put a little bit of this in there or this, or they think they know something different. They read an article online. They watched a YouTube video, and it's like, that's not what we need. We need this, right? So you have to be careful with that. When you walk in to a company, you got to earn that trust, right? It's not just given. I know we kind of think that respect and trust and all that just has to be given as soon as you walk in the door. That's not the way it works, because why? There's projects and companies on the line that if something gets screwed up, a lot of people pay the price. So when they need certain things done a certain way, very specific, you may not understand why, but that's okay. Do what is asked. Once they see that you are able to produce what they want, then you can start sprinkling your ideas here and go, oh, you know what? I was thinking about doing this. I was thinking about doing that. And, you start moving through. I think if you've ever heard bloom where you're planted, blossom where you're planted, right? You kind of get there, root in first, and then start showing, 100% what you do. But you got to show that you are a working part of the machine first and do things that just people ask you to do. And yes, it stamps on your steps and crushes your artistic freedoms, but whatever, right? Yeah, it's a job. It's a job. That's what it is. So yeah, it's kind of interesting. And then to hear that, I honestly thought that companies weren't all that, quad anymore. I mean, you see a lot of models out there that might have a triangle here or there, might have a handful of triangles, no real big deal. Most renderers support that. There's got to be a reason why. Could be something with the approximation editor. If they're rendering a certain way to, remember we were talking about getting resolution independence into a polygon model. Sub-Ds don't like non-quad geometry. So actually to the point where mental ray, would omit those surfaces, even though it would show you in your viewport when you rendered it, anything that had a non-quad in its base mesh before it was turned into subdies would vanish. It just wouldn't render. So if they're working with 2014, that could be one of those things that they're running into. Might be why they're forcing the quad. We just know quads work, so might as well work with quads. So that's, you know, something to be thinking about. Let's see what else we got. We're gonna get into this stuff here in the good old lecture. Well, it says lecture 9. It's not really. Well, I guess it is lecture 9. It is lecture. We've got 9, 10, and 11 to finish off the week. You guys know that you don't have lab on Friday. It is a lecture only. The integrated has been removed. I don't know if Caleb's going to be there, and I don't know if production modeling has a lab, but usually production modeling does have a lab. Whoever's watching it will say, hey, you're more than welcome to show up, but Caleb might be somewhere keeping a room open, because we do have the room for the integrated time. You don't have, I mean, I will verify if Caleb's going to be there, and if he is, then more than welcome to go in there. Okay. All right. So week 4, final week. Where does a model go from here? Right. What do we do with it? Right now, we've got a look, but we have to look at processes for future asset development. Where do we go? What do we do before we get into tertiary details? Before we start sculpting that really high-end stuff? How do we make sure the asset works? You know, looking at things like hair and sculpting hair, that kind of stuff, right? That's what we're going to be focusing on this week. Usability is also going to be a big discussion, especially with topology usability. So, you know, we'll look at the assignments, we'll look at the anatomy for the ear and modeling process. Just follow the video, please. I get too many people, everyone will model a human ear, whether you like it or not. You're going to model, unless you're like, I don't want those points, I'm not doing it. Follow the video. There's a supplied video. It walks you through modeling in Maya. There's one, I love it. It's my video from 2009. And I leave it in there just for the heck of it, because I know it bothers some people. They're like, I can't follow this video. It's in Maya 2009. There's really only 2 things in the video that have changed from today. 1, split polygon tool is now the multi-cut tool. And 2, when you hit the 3 key, somewhere along the line, they made it, the 3 key only works on a 3-dimensional object. Like it has to be, you can't just make a plane and hit the 3 key on it anymore. Used to be able to do that. And in the video, I trace out the ear with the create polygon tool. I hit the 3 key to make sure it fits the shape of the ear. You can't do that until you skip a couple steps and you extrude forward, right? But it doesn't kill, you should be able to watch and get through that. And I mean, in 2002, when I read a tutorial, that's the process I liked. So 2009, I made a video tutorial on it, changed a couple things, how I liked to go through the process. And I think it's still a good way to model a complex structure inside of Maya. There has been an updated video put in there. It is modeling an ear. I think it was done a couple years ago by James Davis. Slightly different modeling approach, still both modeling in Maya. We are not sculpting human ears. If you do that, you will get a 0. It will be deemed incomplete. It's got to be following one of those videos, okay, modeled in Maya. So just want to make sure that's clear. And both videos do stop at the final shaping, okay? If you model them and you end at that, you're probably going to end up with a B, right? James says it throughout his video, and I'm always saying it whenever any one of my videos, you know, modeling, you're always shaping. Make sure that you shape it. And when you're done with, especially the one in James, when you're done with it, it looks like an ear biscuit. It's flat. It doesn't really have the depth it needs. I mean, you look at an ear, there's some crazy stuff going on in an ear, right? All that cartilage and, you know, shape that needs to be in there. So when you're done with that video, or even the one that I did, the older one, you want to make sure that you continue shaping it to kind of add that extra life and realism to it. So we want to make sure we're doing that. It does not have to be attached to your character any way, shape, or form. It is just a modeling exercise, modeling an ear, right? You learn the helix, antihelix, concubule, right? earlobe, basic stuff, ear canal. And it kind of keeps you in Maya a little bit, kind of keeping those Maya modeling muscles working, okay? Let's see, we'll look at how to break down a hairstyle for modeling. Again, just another look at reference, kind of looking at hair, figuring out the parts and pieces, right? The gatherings, the clumping of hair, and then looking at the direction. The direction has a lot to do with how you model it because you want to feel the flow of the hair in your model. So we'll be looking at that. Techniques for creating hair for a character. We know all the tools at this point. We're not using hair systems. We're not using XGen. We're not using shaving a haircut, fur, nothing. We're not using fiber mesh or anything like that. You can spend 2 weeks, 3 weeks figuring that stuff out to get something decent. Those things are great, and they're really pretty easy for getting a simple hairstyle out, but anything that's complex, a lot of times they'll resort to modeling and then push that model into hair information, right? So modeling is still a big part of creating hair for a lot of assets. And then if you're going into game, you're going to be doing a lot of card systems and parts and pieces anyway. But we'll take a look at that. We'll look at rules and ideas of good topology, right? The resurfacing. Now we're only going to have time to do a head. You don't need to do the whole body, right? That is not part of the requirement. We're just doing a face, right? This is where most of the thought goes into topology, is in the face. Most everything else has become pretty simple with a couple key loops and things, which we'll talk about. I'll show you one that's going through the process. But remember, we're only doing the head for our characters, and we'll be going further with that. But we'll talk a lot about what makes good geometry and what doesn't. We'll look at the process for resurfacing. In Maya, we'll be using Maya Quadral for that. UV's do's and don'ts, creation and layout procedure. I mean, a lot of that is stuff we already know, so we'll gloss over that. Super quick process. Takes me about 30 minutes to talk about it. It'll take you about 15 minutes to complete on your asset. Call it done, get those points, and move on. Normal maps, do's and don'ts, creation and application. We'll just set it up, click a button, done. So UVs and normal maps, 15 minutes. Tops is what you're looking at process-wise there. And if you're like, no way, UVs, I hate UVs, that'll take me way longer. Hopefully, I'll change your mind on that and show you how we can just do a 1, 2, 3 process. It's done. We hit the settings, click bake maps, and there it is. Right? We got that finished up, and you get those points. Okay. So a reminder: these are the assignments for the week. Does it say continue sculpting your character? No. I say this every month, and I think last month, the Friday of week 4, I had about 5 or 6 students that walked up to me and said, hey, I've been working on my character trying to make it look better. I just wanted to get a critique and to see what else I can do. And I looked at them like, you've been doing this all week? Yeah, I just really want to make the character look good. I said, have you resurfaced the head yet? Oh, no, I'm just going to do that over the weekend. Have you done the hair yet? No, I really just want to make this character look awesome. And I go, stop working on your character. Start doing the assignments that are graded for this week, okay? Because those are where the points are. Yes, there is a final evaluation. We do look at your character, but it's more of what does it look like now that it's brought into ZBrush or into Maya. I can zoom in on it. I can really kind of rotate around it, look at it. I can see what it looks like with the props next to it, right? It's just kind of a, hey, what does this look like? So if you've got time at the end of the week, after you've got everything else done, to touch up some things, yes, that would be a good idea, but prioritize. Make sure you get the assignments done for the week and then get into finishing touches on your character. Yes?
Wait, so for the hair, do we put that on the character?
Mm-hmm.
Okay.
Yeah, but we're sculpting that as a separate piece, but we're not going in and go, well, I wanted the clothes to look better, At this point, you almost look at it as it is what it is. If you do manage your time right, there's nothing stopping you from watching the playlist videos where I talk about the hair. It's in the last one, the last video. You can watch that. Probably take you a good day to do the hair, half a day to resurface your head, 15, 20 minutes to UV. You follow the tutorial videos for the modeling the ear. There's 2 hours there. That gives you a little bit of time to bang through adding details or extra stuff to your character, but do that after, because you miss any of those elements to mess around with your character, as those are big hits, because that's not where the main points are for the week, right? So just want to kind of make sure that we're on the same page there. You will be doing a leg study and hair breakdown. I have removed, if I haven't, it will be removed. I'm pretty sure I did, I don't know. But the final evaluation, we used to have in there that you would evaluate yourself. And I don't want to say that it wasn't important, but I want to give you as much time as possible to get the assignments done. You should always be evaluating your process, your project, your end result after every class, everything that you build, what worked, what didn't, right? What you would change next time. Maybe you learned a couple things. What wouldn't you do, right? These are all things that you want to be thinking about as you evolve your skill sets, your skills themselves, right, and your asset library. If not, can you imagine if we just did stuff and go, that worked well enough, I have no need to change it. We'd still be looking at graphics from 2000, okay? But they're always going, all right, cool, that worked out. How can we make that better? And we advance, okay? Just don't advance yourself out of a job. That's never good. Have a plan for anything, right? No matter what it is. Just, you know, I know we're talking about under lake study and the hair breakdown, but have a plan for all your assignments. Use your resources. Stay focused. I haven't talked to Caleb. Has anybody been hitting up the Discord, getting some help from him? Yeah, good. Thank you very much for that. That's awesome. I found, honestly, you know, people sometimes say, well, I don't have time to help out. But what I did was, one, I knew I wanted to teach, but I spent a lot of time zipping my chair around the labs and helping my classmates. And by the time I got back to my table, I already knew everything I needed to do. I just did it super quick because I had literally done it 5 or 6 times by the time I needed to do it. So it does help you. When you give a critique to somebody, you're training yourself more. So it really does help. When you sculpt overs and stuff, you're practicing doing shapes and things. So it's not a bad thing. So I definitely appreciate that. We all need to kind of, the only time you don't want to help each other is when there's only one position at a company and you know that 3 of your friends are applying for that. Then you do what you need to do at that point, right? No, you're all like, oh, he told us to stab each other in the back and take advantage of the situation. No, I didn't say that. I'm saying, you know, yeah, do what you gotta do, you know, job in line. Let's see, stay focused. Don't worry about the things you're not supposed to be worrying about. Worry about what you need to worry about. And of course, always be observant. Has anybody started a planning process? Anything they want to share? You know, what's worked really well for them to keep assets or procedures, you know, time management, process management?
I made labels and Ziploc bags for my cords instead of shoving them in my book bag. So
Well, that for setup, I should probably do that because I forget what pouch I put what in, and I'm like, wait, where's that? I have started though. I have started using this for my smaller things. So, you know, it does help out. Anything for your projects? Anybody using program like Trello or Excel or Numbers or not Numbers? Was Numbers Excel? I think Numbers is Excel for. Yeah, Google Docs, right? Where you write down your schedule broken down into the quarter hours, and then as you're done, you kind of erase or block out done. No. Hey, if you got ADD like me, you're going to need to start finding stuff like that because you'll find that you can move a lot faster than you think you can if you organize, right? And it's got to be something streamlined, especially if you are a little bit on the ADD side. It's got to be something that is not more work to where you don't want to do it, right? It's got to be, that's why I always like legal pads, because I can just write really quick and just, you know, pen, write, scratch it out. If I have to go into an application, that's, I got to open this up and I got to type, and I'm thinking about what I'm typing, and then I'm like, oh, what's on Facebook? And oh, I need to search for this product thing that I need to get for my, you know, and gone, right? So I got to keep myself in the zone. Okay, cool. Woot. Leg study, remember écrochet. We're doing écrochet style sculpts, identifying the muscle forms and bony landmarks. This is an example of the hairstyle breakdown. We're going to be breaking down into parts and pieces or layers, and then direction. So when you're looking at your character's hair, the best thing to do is to find a realistic hairstyle that represents what you're seeing. There's got to be one out there, and then go through and work with that. I mean, this is great because it's got multiple views and you can kind of go through each one of those. But this also helps when I go into sculpting hair detail. those arrows help when I'm getting in and putting in the strokes for the hair, right? Because I'm putting them in the direction that I've drawn the arrows for, okay? Here's an example of the ear modeled in Maya. Yeah, we can sculpt an ear pretty quick. I mean, you can sculpt an ear pretty quick, but to build the usable topology or get something that's a little bit, topology wise, you know, the reason we have you do it separate is not because this is the best way to do an ear, but sometimes you'll run across things that are more complex and you don't want to sculpt it. So you build it in Maya and you bring the two assets together. Because right now, when we're going to resurface, right, if our character doesn't have an ear on their head and we're resurfacing and I can build an ear faster than I can sculpt it or whatever the reason would be, now I've got my resurfaced area, my resurfaced head, which will go back into ZBrush, but now I can pop my ear onto that mesh, bring it into ZBrush and continue sculpting. Right, so you have to understand that a model just isn't sculpted and resurfaced. There is modeling procedures that happen in the resurfacing stages, and when you're resurfacing, there might be sculpture things that are going to happen to that asset after that, right? So we've only gotten the first portion, I'd say the first third of the modeling process under our belt right now with where we're at. Okay, we're going to look at that transition from the first third into the second third, and then the last one would be like your super high tertiary details and things like that, and baking all your maps and making that stuff work, right? But there is definitely a lot of stuff going on. You'll be getting that more in production modeling and as you work in your other classes, okay? So resurfacing, this is exactly what you're going to resurface. You're going to resurface the head of your character. You go around the ears. If you have cartoon character that doesn't really have a lot of facial details, I would recommend doing the ears, right? Just because the face might be a little simplistic, but if you've got a good human face that's got the eyes and the nose with nostrils and lips, there's usually enough there in the asset to work with. Or if you feel that your cartoon character has enough of that shape and detail in it, then we do what we do. But this is roughly a nice solid base mesh. This is one that I've used for years. It works well until you get into older characters or younger. Right? This is kind of good for when the skull is solidified. Once you get into jowls and different things like that as age takes over the skin, then you might need to change this a little bit. But this is the one I like to run with, and it works out all right. And there it is. If you wanted to use this, if you're doing, anybody in here is doing a standard human character, you can reference that topology. Okay, I'm going to tell you that anyway. You should be referencing topology. Unless you've built several models and developed your own topology, use somebody else's, right? I don't mean use their topology and shrink wrap it to your character's head, but when I was learning, I did a lot of, okay, here's the center line, let me count. There's a star junction there, let me count. 1, 2, 3, 4. Cool, let me, quadro didn't exist, so let me extrude 1, 2, 3, 4. And then there's this many lines to the hairline. Let me extrude up 1, 2, 3, 4, 5. Right? And I would extrude and I would count my way through the asset. And that kind of really taught me why geometry was where it was, or why I thought it was there, why I would put it there. And then I started memorizing the layouts, okay? Because most of the assets you see will have very similar layouts. We'll have an ocular cavity or a radial loop around the eye. We'll have a radial around the mouth. We'll have some sort of muzzle loop. We'll see geometry flowing in certain directions, and this kind of stuff has been standardized over the years. So I would strongly recommend searching the web, finding yourself a good topology. We've given you some of that information, and there's this one here that's online. It shows front and side. It's definitely usable, and it can be modified for a cartoon character if needed, right? The difference is you might have 1 or 2 extra or 1 or 2 fewer edges throughout the asset. This is also a good example. Awesome. Don't know what I hit there, but this is a good example as to the density or resolution that we're looking for. Okay. I see a lot of people go really light on their model, or they go super heavy, right? So visually, this would be kind of what we're looking at. We're not looking to build in scars or anything like that. We're looking at just a nice clean wireframe for the head. And I'll talk about why that's a good wireframe. What makes that better than this one here that's older? Still the same principles behind the wireframes, right? If you look at the base layout, they're very similar. But why this one is less acceptable nowadays, hint, as to this one.
The one right here holds the shape better, like around the areas where there's curves and stuff.
Okay,
It's kind of holding more like the cheekbone, the nose area to kind of get a better smile or move the mouth.
okay. But if you look at the base, because you guys are right, but why didn't I do that on this one 7 years ago? Why is this? Because if you look at where the star junctions are, they're pretty much in the same spot all the way through. It's got a loop here for the mouth, geometry flowing out of the head. It almost just looks like this is a smooth version. So it's the same topology with more geometry in it because we can spend more geometry. Computers are tougher, softwares are more diligent with running topology. So we can spend it, let's spend it. And it does, it allows us to hold the shape better. In deformation, it holds better. It just works as a stronger asset. And I can talk to you all day long about density levels and parameterization, which we will talk about, as to why this one starts to fall a little shy. You can feel a little pressure. If you look over here in the cheek, right? So you were talking about holding the shapes better and holding the cheek better. This geometry is starting to get stressed out, right? Starting to get pulled. It's kite. I think we talked about kiting a little bit, but this one here just has more to help relax it, right? You ever have to pick up something heavy? Well, you get some friends to help you out. It's not so heavy anymore because you've got assistance, you've got support. Same thing here. We've got more geometry. We can alleviate the tension on the surface and help the overall quality and functionality of the surface. But we will be laying out UVs. We're going to do a real simple UV layout. We're going to try and maintain a single UV shell. The reason these are here, these are inside eyelid portions. This is inside the nostrils. But, you know, again, with more topology, we're going to go with something like this. I go for maximum usage of 0 to 1 space. We're only laying out a character's head. So this is why I put it at a 45-degree angle. Normally, you're not going to see this. Normally, you're going to see just vertical, horizontal style layouts. They're a little bit easier to manage, easier to organize. But since we're only doing a normal map, right? Purpose dictates process. If we're only doing a normal map, and my goal is to maximize resolution, I'm going to use up as much space as I can. You know, with some ideas and rules and things like that taken into consideration. Because honestly, if I broke this into a bajillion pieces and packed them all in to all the dead space, I would maximize resolution. But now I've got a ton of seams to worry about. And seams, even with paint by number programs like Substance and all that stuff, you're still going to see your seams. Okay, we will be doing a normal map, super simple bake, nothing special. The one thing I do want to mention about normal maps is they're great. We do them because MCR was really doing normal maps. I know in shaders and lighting, you talk about displacements and bumps and things like that. I don't want you to think that normal maps are the end all be all. Normal maps are okay to sell the illusion of more geometry, but when you get into things like fine lines and wrinkles, pores, bump maps are really nice because they're cheap and you can adjust. You can layer them and adjust multiple things and depths, but vector displacements are amazing as well. That's the next evolution in mapping, right? Is a vector displacement. Not only does it, like a displacement map, go forward and back, but a vector displacement goes forward, back, left, and right. It can actually create volumes through the maps. Really, really cool. And there's been a lot of stuff there. But normal maps are just one map, so don't overuse. I would say don't overuse anything. A nice mixture of things is usually the best way to go, right? So you can get the strengths of things, strengths of other things, and kind of let the weaknesses be washed out by the strength of something else. So, but yeah, we'll just be doing a normal map real quick, and then just showing you that the model is done. We'll be doing the hair. A lot of people do ask, what if my character has hair but you can't see all of it. Do I need to do all of it? Yes, yes, because I've seen people go, well, I got one little bang strip there and I'm just gonna do that. Now, what do you reference for that? Right, so when I put my hat on, my hair does not vanish. Okay, it's not gone, it still exists. I take it off, I got a hat head, right? So I would reference stuff like that. What might the hair look like in that hood? And because we're our gods in these programs, we can hide and layer and do all kinds of stuff. So we can have, if the hood comes off, we can unhide the hair, you know, and I can look at it and evaluate. So there are definitely ways we want to make sure that we have that. Then also the question comes up, my character doesn't have hair, what do I do? We talked about this, somebody asked that last week, or yeah, it would have been last week because today's Monday. Right, so if your character doesn't have hair, you can either design and give them hair, or you can select one of the things that we have supplied. We've got 2 human heads and 2 cartoon heads. I also open it up to allowing you to use the ZBrush heads, right? So anything that's supplied in ZBrush other than the hair that is supplied in ZBrush. I think the Julie model has hair roughed out on it, but most of the other ones are no hair on them. But you can use those and build hair for them if your character doesn't have hair. Now I've seen, again, the past couple months, I don't know where the confusion's coming from, so I got to do some digging, but I've seen people model the hair on their character as well as select one of the head busts and model more hair. You only need to do one. It's your characters. If your character has hair, you do that hairstyle. If they don't, you do one of the other options. Okay, so that's the only 2 ways to go about it. I only grade one of them in that situation. Okay, so it's not like an extra credit thing or anything like that. All right, so let's get into topology. I love topology. I love topology because I was born and raised in the 3D world building topology, right? Now we sculpt, and topology almost seems like an afterthought, but it really isn't. It is the usable mesh. It is what gets rigged. I was talking with, actually, she comes in after class. She's helping out with the animation for the game art classes and also teach some of the other stuff. But she's a Disney animator. She animated on some Disney films. Her and her husband, Paul, which you'll get Paul in production modeling. They were both animators from Disney. And we were talking, I don't know if it was the last class or the class before, about how we see all this wonderful stuff out there, but it's not usable. Right? If you get onto ZBrush Central and you want to feel bad about yourself, get onto ZBrush Central and just look at all the new sculptures. And I did this on my lunch break, which a lot of times I don't really believe that, but you see Lunch Crunch. I think it's called Lunch Crunch, a little group that, yeah, they're like, it must be taking a 6-hour lunch. But they sculpt, and none of that stuff is usable. What we have now is not usable. You could, I don't think it would work, but you're not likely to throw a rig into our meshes now and use that. Maya's not gonna like that, right? Has anybody done some rigging? Okay, well, I know you have your class next month on how to rig. Everybody should know how to rig, just like you should know how to animate and do everything else. But rigging, I think, is fun. I think a lot of people like rigging because it's very yes or no. As far as this either plugs in and works or it doesn't, or you have to figure out how to plug it in. If you've ever hooked up stereos, you know what I'm talking about. You're like, this isn't working. Let me change the input and then hook these speakers up that way. It either works or it doesn't, or you fry something. So it's the way it goes. So rigging is kind of cool, and you have to understand rigging because a modeler will test bind, right? We will either try and sculpt and form what the asset needs to do to make sure our model can do that, or we'll just throw a rig in it really quick and bind it up and say, and when I say binding, I'm talking about connecting the vertices to the joints, to the bone structure, so you can move it around. And we do that so we can either pose really quickly, or we can test bind and check out our rig, or check out our model, make sure that it's flexible enough. If I can get it to 70%, I know that the setup artist will be able to get it to where they need it to go. And if they can't, they'll come back and they'll say, hey, can you make that look better? So we'll take a look at an asset. It's the guy you've seen before. I'm going to bring up the monster guy wearing the thing, the hat and the flippy flops. Right. Actually, no, I'm going to bring up, well, yeah, we'll look at a couple things. We want to look at stuff first, and then we'll talk about the procedures. So we'll look at him first, and I'll show you an asset that is being done with him. Okay, so right now the body for this character is 3.4 million. All right, and I'm starting to get into, well, for the mouth, every time I up-res my Dynamesh, the mouth kind of gets a little pixelated. I lose that sharp line. So I'm like, yeah, it's time to resurface him. I'm losing, you know, flexibility for shaping. I don't want to take it up further than it is. And if I subdivide 3.4 million, I'm at what, 12 million, right? If not more. So I don't want to do that, right? So now I need better topology. I need to tell it, let me give it more geometry in the face. So when I subdivide, I get more focused geometry there, less geometry in the body, more geometry in the hands, right? Start building it how I need it to be. Geometry that will hold the shapes exactly the way I need them to be held. So what you do there is I went ahead and I took it and I decimated it. I decimated it down because Maya doesn't like 3.4 million. Right? It doesn't want that. So I decimated it down to 1.3, which is still quite a bit for Maya to worry about. And there's a lot of, I mean, I have an older machine, so again, and we're on Max, right? Not the best for the 3D world, but you know, I don't want to push my limits all the time. So I decimated the model down. And some people go, well, if you decimate, that's a lower resolution. Why don't we use that? Well, if you've seen decimated geometry, right? It's all a big triangulated mess. And if you haven't, we'll take a look at it. Right? That's not gonna, I mean, there might be a day. I think that day is within 10 years. I definitely think within 10 years, so the topology argument may become less of an issue. Definitely for film. For video games, I think we might be a little bit further off. But, you know, when you're talking about, what was it, Ender's Game, when they had over 1 billion polygons on screen in that last battle, the ships all over the place, blowing everything up. You know, that kind of stuff was unheard of. You just, what? You know, and now you're seeing more and more 3D elements on screen at one time because the computers can calculate it. So there might be a point where they say, oh, what, 15 million per character? Nah, that's no problem, no big deal, right? I think it's once they start dealing more with voxels, voxel information. It's more like a volumetric pixel. It tessellates a little different, but you know, maybe we can get into that more like a physical thing on screen. I don't know how to explain it, but I think there will be a point when, again, computers and processors, they run it, no problem, you know. So that'll be less of an issue, and it'll all be about shape. But right now we're there. And when you get the jobs, there's going to be companies that are still working on older procedures, right? The rules for that one company that's using Maya 2014, their rules probably exist from 2014, right? A lot has changed over that amount of time. So you never know where you're going to end up, and you got to kind of look at what's important. So neither of these meshes are riggable and acceptable for a production pipeline. So our job is to make them acceptable. So I take this asset out, I decimate it, try and make it as efficient as possible, maintaining shape, because I'm going to source my sculpture to build the new topology on. Okay, that topology, once it's built, will be brought back in. I mean, if you build it right in ZBrush, which you can do, I don't like it. I think Maya's tools are much better, stronger, they're easier to work with. I'm going to either stay in here and do more work on it sculpturally, or I'm going to go ahead and bring the asset back in and continue on it sculpturally, right? But We're just looking for better, more usable final topology, okay? So I take this out and I export it out of ZBrush, and we're gonna go ahead and look at this one being resurfaced. I think he's in here, Jersey. Head resurface test 2. I believe this is him. I made a mistake on the Jersey. Tried to do something I shouldn't have, and everybody warned me. They warned me. I was like, now I'm gonna make it work. I was stubborn, teacher stubborn. And now I'm paying for it with a lot of manual correction and fixing. But it'll pay off in the end, I guarantee. Okay. So he's been brought in. And he's being resurfaced. Okay, so there is his main mesh, and here are the resurfaced parts. Okay, so right now, I thought it kept, we're in 2019, so hopefully things go nicely. So we went from 1.3 million, let's say 1.4, because I think it was 1.37, to, what is that, 4,000, say 5,000, so 10,000 polygons. And it looks structurally the same if I soften normals on all this stuff. All my structural elements, I hit the 7 key to test out silhouette. Silhouette's readable. There'll be a little bit more. This thing will need an eye bag and a mouth bag, right? If it's gonna open up its mouth, I need to be able to create that. So there'll be more geometry in there. But the base model, the base body, the head is under 2,000. Look at that, the head and the body are almost the same amount, give or take. All right, so once this gets duped over, we're sitting under 10,000 polygons, maybe 10,000 at the most, and we're gonna get more functionality than 1.3 million, right? Or even 3.4 million. So this is where we get that. Now, normal map, displacement map, bump map, that stuff will give me that illusion that there's that much geometry, because this topology, I can't get those little irregularities in the skin. I can't get wrinkles and things like that, you know, but I know that if I cut that stuff in, that information in manually and do it in the topology, I can still keep this thing under 100,000 polygons for the body, which is that's 10 times more efficient than the decimated unusable mesh, right? So this is what we're going for. Now, I've got it broken into pieces. Remember, you do not, I'm not gonna say you don't need to, don't do, I'll just change it to that. Don't do the body. That's not gonna, it's not what we're looking for. We're looking for the face, head, right? You can see he doesn't have an ear, so I did what would be his head. It is mirrored over. We've got radials for the eyes, radial for the mouth, geometry following a lot of the shapes, right? And then since he needed it anyway, I started getting into the rest of the body. So as far as loops go, if you've ever heard somebody talk about edge looping, and they might have thrown out a term like the cape loop, right? No? Okay, well, if you get into the modeling game, you might start hearing people talk about that stuff, right? So there are edge loops. So an edge loop is nothing more than edges that are end to end, right? An edge ring are the edges when they're parallel to each other. Okay, so when you do split edge ring and you're inserting an edge loop, that's because you're cutting through these edges that are parallel to each other, right? So I always look at it like a ladder. The sides of the ladder are your edge loop. The rungs of the ladder is your edge ring, okay? So when I talk about edge looping, though, I'm talking about how I'm using my edges to flow geometry through a model to encircle or encompass areas. So you can see I have a radial around the eyes Okay, that is a clean radial, and I can pick walk through that. Pick walking is when you use your arrow keys to navigate through your model, and it needs clean edge loops and edge rings to pick walk correctly. You can see here I can go to edge rings as well. I can start pick walking through edge rings, and I can switch to whatever. Now, if your model is not built properly, you'll get lost really quick. It starts and you start getting away. But a rigger wants to see nice radials. They want to see nice, clean edge looping. So some of the edges have started getting names. Not started, they've had names. I mean, I've known a cape loop is something that I've put in my model since I've started. A bandit mask, right? Ocular cavity loop, scapula loop, abdominal loop. These are just areas that we might loop. We might put loops on. We used to have bicep loop or a loop for the bicep. That kind of stuff has gone away. Models have become less complicated with their topology layouts and more uniform and clean with their topology layouts with key loops in key places. We're not looping all the way through because of the advancement of maps and things that can help with that. So you'll see here we got a radial around the mouth, a radial loop for the mouth, going all the way to where the lips are. In the body, we do have a cape loop. This is the cape loop. I'll grab the one that's just above the cape loop. Kind of looks like a cape going up and around. Sometimes you'll see this shoot through the back, similar to this one. But it is a loop that goes under the pec or breast shape, up through, over the arm, and either down the back or across the back. He's got kind of an abdominal loop. He's got something in here to turn the geometry there. Not sure if I'm going to keep that. This body form is different than a standard human. So there are, I'll show you where I'm running into areas that I need to kind of think about a little bit more. I don't want to just add in an extra junction. You'll see this junction here. This is a diamond junction, right? So I'm taking one edge and I'm splitting it into 3 edges. So we're taking one edge, splitting into 3. And I like this one because it sets the line for down the arm into the connection between the arm and under the arm, right? So that's something I like to do on my models. I use that one. It also helps me condense as I get towards the face. But I don't know if I'm going to need to keep it because the head's pretty dense compared to the body. The other thing is his body shape. He's rolled forward and he's got the big bowed back. So I'm already feeling compressed in the front. What do I do to expand that topology for the back? Because the back, if you were to look at the sizes of the polygons, big difference front to back. Okay, so I don't want to just throw in extra edges to make this feel all right because it might hurt this. So I am always thinking globally, and it's to the point where I might have to talk to a rigger and say, hey, is this even going to be a problem? Or is it something that I want to think about? And if so, is there anything you would want to see if you're going to rig it? What would you want to see in the topology for the back, right? That way I'm kind of getting a little bit more into functionality. I mean, it works okay the way it is. We've got just a little expansion for the elbow, keeping everything else pretty simple. I always like to put in a little radial for around the toe. These radials are being used box junction, right? This is a box junction. Okay, so we're taking an edge and we're turning it, connecting off to the side. You'll see another one here. You actually see a couple of them. All right, it's just a simple radial. You see diamond again in between the toes, and to close that geometry off on the bottom. But most of the toes are the exact same topology, other than the big toe, because it covers more ground. You'll see the same similarity in the hand. Gotta finish off his finger there. But you'll see diamonds being used to expand geometry for in between, and you'll see box junctions to hold the nail bed on the hand. But everything else, if you look at the rest of the model, pretty standard quad style topology. Okay, so what am I thinking about while I'm building? How am I thinking about maintaining this topology? Because I'll tell you, the model that I built, my first model ever, a female model, it's terrible. That topology is terrible. It would never pass. I mean, high res was 6,000 polygons. It was 6,400. So you were counting your polygons and trying to figure out where to put them. So you had a lot of star junctions, right? We're familiar with what a star junction is. Okay, so the rule nowadays is really you want to maintain 5-point stars. 1, 2, 3, 4, 5. Anything more than a 5-point star is something you really don't want. Back then, I had 8, 9-point stars, 6-point stars, all over the place. And it was good topology, right? Because that's what you had to do with polygons. Now it's a little different. So as I've seen topology evolve over the years, there have been some things that have pretty much come to be rules of topology, things that I like to use that I found helpful to me when evaluating and building topology. So let's talk about that really quick. I'll have to mess up some of this to make some bad stuff and then kind of look at the difference. So the first thing that you want to be thinking about with your topology is shape. Okay, does the geometry that you're creating, is it capable of giving you the shape you need? That's pretty important, right? Because if you don't give the right topology around the nostrils, you're not going to be able to hold the nostril shape, the outer portion of the nostrils. You won't be able to get it because the geometry will fail you. Now, when I say you won't be able to get it, you won't be able to get that shape with efficient topology. You throw millions of polygons at it, yes, you will be able to get that shape, but that's not what we're doing nowadays. So that's a consideration. Do I have, when you looked at the geometry here on that other model and people said it holds the shape better, that topology was stretched out pretty good in the older version, but now I can use more topology so I can put a little bit more in there to help achieve the shapes I'm really going for. Now, what other types of shapes do I need to be concerned with? Because as it sits, this model looks fine the way it is, but why am I concerned about, it looks fine now, but why am I concerned about the back? Why am I concerned about some of this other topology? Because stretching,
Stressing, kind of like move it.
yeah, moving, animating, right? How many people Looney Tunes stuff? It's kind of funny. We were just talking about old cartoons. I put on Donald Duck. My kids love Donald Duck. I mean, he's my favorite if I had to go into Disney stuff. And there's a whole episode, a whole Donald Duck cartoon about smoking. And a devil Donald Duck shows up and he's like, yeah, come on, light it up. And I was like, what is I had to turn it because I was like, but I watched that when I was a kid. Like, it was no big deal. He's all smoking it up and, and he's, oh, you feel sick? Keep on doing it. It'll get better. And you're like, what is going on? But besides that, old, Bugs Bunny and stuff, right? When he did the flex and then the arm went and dangled and if you tried to build that into a model, how much topology you need in this area to maintain that arc and that flexibility in the asset, right? So I need to think beyond just this default pose. I need to think, what will it do? What might it do? And that's going to tell me where I need to pack geometry in or even stuff out, or I need a special loop for this specific movement. So all part of the thing. And that's a plan in my topology. Will it achieve shapes not only in its default state, but in an animated state or an extreme state? And just so you know, this is a base resolution. Okay, so that means that the rigger might rig this and weight it at twice the amount of topology. Okay, so it really depends on if they're going for something simple or if they're going to want a lot more movement. So it might end up being smooth at least once, possibly twice. Okay, so that's idea number one. Does the geometry deliver the shapes I need? Or not deliver, because you're the one delivering the shapes. Does it allow you to get the shapes you need? Okay. The other thing, number two, is, let me see if I can find, I want to bring up that model. Because I think he's fun to look at, or it's fun to look at. Is it good geometry in general? That's the next idea or rule behind topology. So what am I talking about there? What have you been taught in geometry? Is it good geometry? What are some of the things you've been taught about topology? Okay, faces on faces, lamina faces. It's kind of crazy. One of the best ways to get rid of that is by merging all your verts, creating lamina faces so cleanup tool can get rid of it. Okay, so faces on faces. That's a problem, right? What else? Non-planar faces. See, non-planar faces gets a lot of people. If you're doing hard surface stuff and games, right? One of the reasons that a triangle is so legal, even though we're told not to use them, but a triangle is the most legal form of a polygon is because it's always planar. But when you have a quad, to keep it planar is almost impossible unless you snap it to the grid or flat. As soon as you tweak one of those verts, even just a nano grid, whatever your measurements are, it's non-planar. So a lot of times people will run that and go, I can't get these all planar because it's pulling all these different faces that are all just twisted and bent. So that's a good one. I'm glad you brought that one up, because in certain scenarios, yeah, you want to find and get rid of all non-planar geometry, but in organic stuff, we can't help but have it. It's going to be there. What else? What were we going to say? Oh, non-manifold. Okay, cool. Non-manifold, that's a huge one. We don't want non-manifold. What are the two types of non-manifold geometry? Well, an n-gon's okay. Well, let me rephrase that. If you know when and why you're using an n-gon, or if it's in a non-deforming surface, they're fine. They're legal, right? What makes an n-gon illegal is when you have an interior angle, right? That's when it starts to become an illegal polygon. And an interior angle is just, this is that model. Oh God, it's terrible to look at. So an interior angle, so if I take this and I get rid of it, right, we have this n-gon in the leg. An interior angle is when I grab this and I yank it in. Oh, I guess I don't, okay, maybe a little bit of a display issue there. You see how it's breaking into the polygon now? It's going into the polygon. That creates an illegal situation, and it may not render, it might clip, right? So that's one of those things we have to watch out. But as long as I go like this, that's legal, right? It's a legal polygon. It's going to work fine. It's going to tessellate and triangulate when I go to render, so it's going to be fine. I've only used n-gons for hard surface stuff in very rare occasions. I like the challenge of creating all quads. Or I've used them when I know I'm going to smooth a mesh. If I know that I'm going to smooth, I will carefully place n-gons, because that will give me a nicer topology at smooth than trying to fix it ahead of time. So for like extra geometry in the forehead, I'll show you what I'm talking about at some point. I just don't want to show you and be like, I can use n-gons. I really don't want to use them, but in my modeling process, I have used them successfully to get certain things out of it. So want to keep quads, non-manifold geometry. I'll get rid of it. So we got, it's not an n-gon that creates non-manifold. Non-manifold, there's normal-based non-manifold, normals meaning surface normals. And what that is when you reverse, right? You have reverse normals, so you got regular normals here. One of your faces is reversed, it's non-manifold. The other type of non-manifold geometry is when you have three faces sharing a common edge, right? So usually if you just take an edge and extrude out, that's non-manifold. That's not going to work, because you can't, if you ever tried to hit the 3 key on that, it doesn't work. And you generate that non-manifold, right? So that's basically if I grab an edge and we just extrude. Awesome. Right, non-manifold. 1, 2, 3 faces sharing a common edge. Okay, if I hit the 3 key on that, ugh. What are you talking about? Look, it looks great, right? Yeah, right, because it doesn't know what to do. It can't average it. It's non-manifold. So the way it was explained to me to really help me understand non-manifold was, if you can't flatten it out, unfold it, it's non-manifold. So if you take like a reverse normal, if you take that face and you physically, I'm not talking about flipping normals, I'm talking about taking the face and flipping it. Well, now you've rotated the next edge, right? So as you try and fix this and flip it, it destroys the rest of it. So non-manifold, anything that you've learned to look for in the cleanup tool, you don't want it. It's not good topology. We want to stay away from it. On top of that, we're going to look for unnecessarily complex topology. Okay, I see this a lot where people have weird junctions all on the side of the face, and I'm like, why is that there? And they can't tell me, then it shouldn't be there. It should be simplified. Okay, so when you have junctions just randomly in your model, like this model that we're going to look at now has, today's standards, it's no good. All right, so let's take a look at top-notch model back in the day. Look at that. Woo, look at how many junctions are in that arm. We got a box junction and a box junction with another box junction, flying around with another box junction, rubbing around box junction. That's nasty stuff right there. That's no good. The back, we've got a junction with another weird junction, junction, just, yeah. Oh man, look at those knuckles, terrible. Ugh. Look at what's going on there. I don't know, right? None of that stuff needs to be there anymore. We come down to this guy, simple, right? Simple, because a lot of the stuff needed for this was because, yeah, throughout the model, I'm counting polygons. I don't want to be too heavy. So things like this, polygons are what you see is what you get. So the answer to fix this is, well, okay. Simplification. Getting rid of these box junctions, terminating them into each other, and sacrificing a poly count. But again, in 2001, 2002, couldn't do it because you end up with a couple extra thousand polygons throughout the model. We couldn't spend that, right? So now though, we can throw in extra edges to help even things out and everything like that. So if you're looking at your model and you're going, hey, that feels a little over complex and I don't really know why, get rid of it, simplify. Okay, if you look at the face though, the face was one of the first places that got solidified as far as the idea of what kind of topologies people were going to use. So you'll see that one there is not too bad. We do have some funkiness up there, but most of it is pretty standardized stuff other than count. Oh yeah, you want to see how we did global illumination back in the day? There it is. You see all those lights? Basically, you took a sphere. Some of them aren't there. Actually, it looks like only, basically you took a sphere and you snapped directional lights to every single vertice, and then you turn on shadows for every other one, and you made a dome of lights. It was awesome. Now you just click a stinking button and go, I want it to be 12 o'clock in the afternoon. There you go. Render. Oh man, I'm an artist. Let's kid. All right, so now if anybody really wants to tear through geometry, I love fixing topology. If you want this model, I will send it to you. You have to email me for it. I'll send it to you. And the goal is to make it more usable topology, not by resurfacing it, by literally going through and chewing it up like I did with the multi-cut. It's a lot of fun. I think it's fun. You want a little topology exercise? Do that. Okay, cool? Yeah, I'll be waiting for those emails. What? I know. Every now and then I get one or two people that'll email me. Okay, so clean geometry. You need clean geometry. You need simplified geometry. You definitely need some junctions. You definitely need some edge loops in there that are specific for specific reasons, but for the most part, we want to kind of try and simplify things a little bit more. The next rule, edge quality, right? Edge quality, edge flow, edge looping, these types of things, okay? So what do I mean by that? Look at that edge for the shin. Look at the knee, right? This is what I would call nowadays erratic edge flow. Erratic edge flow is when your edges aren't smooth flowing like they should be on a nice organic model. They're not this way because you're literally pushing points to try and get the closest thing you can get to fleshy feel, but with not that many points. So you're left to have to, you hit the 3 key on that, it doesn't look too bad. But when you're actually trying to work with that in one mode and rigging that, you're hurting yourself and you're limiting your options. So what we want to see is nice smoothing edge flow. I don't know why that one's might be the amazing set of lights that are up there. We want nice smooth edges. So if you look at this model again, this is one mode. And everything is nice and smooth and flowing through the asset, not fighting the shape. Yes? One. Yeah. Because 1 is what's going to be rigged. 3 is more of an illusion. It's showing you what it'll look like when you smooth it twice, right? But that's not render, you're not getting that actual resolution. So 1 mode. So you want nice, smooth, flowing topology throughout the asset, okay? This is erratic, right? As far as edge loops go, we've got stuff that's going up and turning, so the geometry is not really flowing. It is using specific edge loops, but again, we want to keep that simplified and keep nice flowing edges and specific edge loops. So for your heads, you're going to be shooting for a radial around the eye. You're going to be wanting a radial around the mouth. I don't care if it's a character with an elongated muzzle or regular mouth. You want a radial, at least around the lip shape. You cannot do a radial on an extended muzzle too far out because you need to start going up and over the muzzle. We'll look at an asset that has that to kind of talk about it. Okay, but you want nice flowing edges throughout your model, and you want edge loops that should be where they need to be. Okay, the last thing, this one gets a little technical. Well, part of it's technical, part of it's not. Density and parameterization. Okay, the second word there, it's like sternocleidomastoid. You'll say it and get it wrong. One day it'll click and you're like, oh, okay, parameterization. And sometimes I still trip over it a little bit. Parameterization is more of a technical term that you'll hear from riggers or visual effects people. Density is more the artistic kind of way of looking at it. They are different, but I kind of put them together because they do play hand in hand with each other. So if we look at this model here, okay, it's got a lot of geometry here, a bunch of geometry there, a bunch in the knees, a little bit in the angle around the feet, and then there's like nothing. It almost feels like multiple models, different resolutions put together. Okay, so the density of this model changes drastically from area to area. Right, and that's not good. We don't want this drastic of a change. Okay, again, different rules back then, totally fine, would rig okay. As long as we had deformation topology within the bendable points, we were good. But now we're not looking at that type of density distribution, right? If you look at this, and I already expressed a concern about the density. See how this feels packed, and as we get around the back, it's the geometry spread apart, so the density there. You're gonna get density changes, right? More geometry in areas that require more shape, smaller shapes. Your hands, your face, your feet, they will naturally have more geometry, but you don't want a start and stop situation where you've got 5,000 polygons sitting next to 500 polygons. That will show up visually, and it limits your ability to blend shapes and do more accurate deformations and things like that. So we want to not evenly distribute density levels, but fade nicer from one density level to another. We want a more gradient change from a heavy area to a not so heavy area. Does that make sense? Okay. Now, in the mix of that, one of the things you'll start seeing in a poorly parameterized, yeah, I just messed myself up. Parameterized model is one, usually they're relying on too little amount of geometry, too low of a resolution, and that forces us to use bad parameter. And yeah, I've been saying it great for months, and then now gone. The parameters, yeah, it's gone. It's gone, totally gone. Right. So what are we looking at when we're looking at that that thing? You see this one kind of looks like a square. That one does not. Okay. That's good. That's bad. Why? Why is something like that a consideration? One of the things back in the day when we were working with dynamics, if you didn't evenly space your topology and you rolled the ball down a plane that was all, we had like 5 edges here and then 2 across that, the geometry would roll and fall through that area. I just, because it didn't have anything to calculate, it didn't have anything to run dynamics on. Because when you're running dynamics, you're running it on the vertices. You're not simulating the faces, right? So you wanted to evenly distribute. And so the more we get into calculating and dynamic simulation, skin simulation, stuff like that, they want a more evenly distributed parameterization. It's wrong. It's wrong. I can't say it anymore. So we want to pay attention to that. And you'll look on this model and you'll see a lot more of the areas. I mean, we're not going to get it perfect. Even Z-Remesher, it tries to maintain, but it can't. But we're at least thinking about it. And even in these areas where the geometry spread out, my density level is different, I'm still trying to hold the spacing as uniform as possible. And you'll see it also in the face. And you can tell when you see something that's done really nicely versus something that's not, you can start seeing those changes and that difference in the surface. So it's something you're just thinking about. Once in a while, I will throw an extra loop in just to even things out. Okay, definitely going to produce better topology. This right here, no. And if you don't have clean edge loops, you can't just throw in an extra edge loop because it'll rip through your model and go places you don't want it to go. And a lot of times when we're working on topology like this and we add an edge loop in and then we zoom out and it's like wrapped all around the body, that's a problem. Okay, so your density parameterization, definitely want to think about that stuff. Okay, so who wants to tell me the 4 ideas and rules behind topology that we just went over? So I know you guys were writing them down, and real important, especially if you want to be a modeler, real important to pay attention. You want to talk to a rigger, they're going to be like, oh, your parameterization sucks. And you're going to be like, what's that? What are they? Anybody? Parameterization, yes, that's one of them. What's the other part of that? Oh, density, all right. Density and parameterization, that's one of them. What's another one? And that's what we talked about under the umbrella of the thing. I've been eating a lot of food and I need to get in better shape, right? Okay. Can your topology give you the shapes you need in animation? Okay. So shape. The other one, right? So that's 2. We've got shape, geometry for shape. We've got density parameterization. We've got you're making bad choices or you're making. Okay, so you want good topology, right? N-gons, excessive tri-usage, heavy star junctions, non-manifold, all that stuff. We don't want that. We want to make sure our model is void of all that. Lamina faces, anything that could be causing a problem. Okay, so good clean topology is the 3rd one. What's the last one? Yeah, so edge flow, edge quality, right? Edge looping, edges. So anything that falls under edges. Do you have nice flow through your model? Are your edges flowing with the shapes, working with the shapes, or is it erratic, right? We don't want erratic. Are we utilizing edge loops properly? Okay, are we putting the radial around the eye? Are we putting the radial around the mouth? How are we leveraging the edge loops in our model? Are they working for us or against us? Okay. Yep, those are the things. So when you're looking online and you're trying to find a good topology to follow, you can use those ideas to tell, is this good geometry or bad? Because I've seen a lot that at first glance appears to be okay, but then when you really get into it, no good. It just falls apart. You're like, well, why is this junction on the side of the face? That's weird, right? So, and those things, they've helped me out. It all came back from, I remember I was modeling my first face and I asked the instructor, I said, hey, I'm having trouble shaping the lips. And hey, yeah, just push and pull points until it looks right. I said, are you kidding me? That's a terrible answer. I can't, how does that help me decide what points to push? And I started thinking about topology in a different way at that moment in time, right? So a couple other ideas I have is geometry has a job. Okay, so when you put edges in, you don't randomly put them in, you put them in for a reason. You know what edge is there to support the eyelid. You know which edge is the eyelid. You know which one supports the depth of the eyelid. Kind of figure out what your geometry is doing on the surface. And that job might change, but you have a better understanding of what it's doing at that moment. And when someone goes, oh, it's not right, or, hey, I smoothed it out, now that edge is far away from where it should be, we know to bring it back and put it where it needs to go, okay? So let's take a look at how we get ready for this process. All right, so we looked at some of those, and there's a lot of stuff in here. I can show you deformation stuff, where just density and parameterization are off and you can't sculpt anymore. There's a lot of stuff there that goes into why these things are things we need to pay attention to. And man, I'm just real excited about all the emails I'm going to get about that thing. You're going to be like, man, I want that model so bad. So here's what we're going to do on this. Now he's got the whole body in the scene, but I don't recommend taking your entire body into Maya. If you want an easier time on this, it's probably better to duplicate the model, decimate the duplication, and get rid of everything but the head, because we're only doing the head, right? That's all we're doing here. If you are going to do a full body, yes, you will need the whole body, but we don't have to do that this month, right? So what I did here was I took the 3.4 million polygon structure, I duplicated it and decimated it. Okay, so decimation again, you grab whatever it is. So I'll just go through the process. Let me hide that one. I'll go ahead in there and I'll duplicate that heavy one. I'll take the duplication. I'll go to Z plugin, decimation master. The defaults are fine. 20% is fine. So it'll maintain 20% of my original poly count. So if you have 1 million, it's going to try and bring you down to about 200,000. Right? Keeping 20% of that geometry. First thing we have to do is pre-process current. Whatever my active subtool is, that's what it's going to process, but it has to pre-process it. I really don't understand why it has to pre-process it. I mean, I know why, but a lot of times I just want to hit the button and have it do what it needs to do. What it's doing is it's analyzing the surface and it's saying, where do we need geometry? Where do we not need geometry? It's going to look at the curvature and everything. And so this way, when I do need to decimate, it's stored the shape information in a cache file. So when I change the settings, it'll decimate really fast for me on most occasions. So this is where you have a conversation with your friend. As soon as it's done, you say, shh, and you get back to work. Right? Unless you can talk and not look at somebody and still carry on a conversation, that's, you know, that's when you talk. And you're like, haha, I got to rule around that. I'll just have my Google Hangout over here or whatever my talking software is, and then stare at them the whole time. And writing file to disk. Here should go a little bit faster. Okay, so now we got that. Now we go right back to Z plugin and we decimate current. You can decimate everything at one time, but I'm not a fan of that. I like to do things, you know, part of the time. So it went from 3.4 to basically 1.4. We lost a lot of topology. Gone. Good. Awesome. Okay, so now I take that one. Let me go ahead and look at just the body. I'm going to switch to my lasso select. I'm gonna hold Control and Shift. I'm gonna hide everything but the head. I'm gonna go to Modify Topology, Delete Hidden. So Geometry, Modify Topology, Delete Hidden. Okay. Definitely, as you start getting into making your own custom workspaces, that's a menu that should be there. That's one of those options that you want to have a button somewhere really quick to get to. Use that one a lot. So now we've got just this. Awesome. And now I'm only bringing 138,000 polygons into Maya. That's way more efficient. Super awesome. Okay. Now we take that. We're going to go ahead and export it out. Let's drop it to the desktop. And we'll do monster remesh OBJ. OBJ format. Save that. Start yourself a new scene. Don't save. Take your monster mesh or whatever you named yours, drag and drop it into your scene. Now, there is something I would recommend checking before you import an OBJ into your scene. Go to File, Import Options, File Type, OBJ, down to the bottom, File Type Specific Options, okay? Multiple object, we don't want that, we want single object. Okay, this will keep your asset together. You can always mesh separate as you need, but what happens here is your mesh could come in, even though it's a single mesh, single surface, it could break it into a bunch of pieces for you, which is not what you want. So I'm gonna go ahead and delete that one. I mean, that one's fine, but I just set up the stuff. Drag and drop that one back in. Hit the F key, and now we're ready to resurface. Let's set up a little bit more. I'm going to go ahead and throw this on a layer, just so I know. Just keep it nice and pleasant. Hi. Hi. Right. And then we're going to go ahead and lock it down, make it live. Now I can hide it whenever I want. Right. And again, it works out. So we got that. We're going to go into the Quad Draw modeling toolbox, toolkit. And we're going to bring up Quad Draw. Now we're just going to go to town, right? No. We're going to jump online. We're going to find a reference image, something that can help us figure some stuff out, okay? Find a likeness, something that works well with the asset you're creating. I mean, this guy, really not much out there that's going to match unless I can find some Pixar style stuff, you know, see what kind of wireframes in. But you have to be careful with a lot of that. They do some weird stuff in their productions. So if you have a question about, is this a good topology to follow, just email me an image of it and I'll say, yeah, nah, or watch out for this. That's not really what we're looking for the class. Push it more this way and so on and so forth. But let's get into starting this, okay? There's something that you'll hear a lot, center lines, right? Center lines are important. You want to maintain a center line down the center of your character. In some cases, this even goes into appendages. You'll have a center top, center front, center bottom, center back. But you want to maintain a center line. But I don't start a model in the center line. There have been some really wonky ways of modeling a face, and one of them was literally starting at the center and then extruding across the side of the face. I would recommend starting either around the mouth or at the eye. Those are pretty easy. I sometimes start here, and that way I can extrude around the eye, or I can extrude around the mouth, or quad draw around the eye, around the mouth, and it kind of sets my transition area. But as far as you go, I'd probably start around the eye or the mouth because it's a radial pattern, right? So a radial pattern just means that you're gonna have an edge loop that goes all the way around that surface, just one continuous edge loop, okay? So when we start plotting points, where do we start and how do we start? Well, let's take that center line idea back in. The eye has a center. It also has a center at the bottom. It has a center at the side, both sides. And then that center, between that center and this center, there's another center. And in between those centers are more centers, right? So we can start going through the asset and just breaking it down this way so we have a good idea of getting this stuff started in a very even way. The only time that this will change is on corners, right? The rule of 3 for corners, any kind of a corner on a building, any kind of a corner crease or anything like that. The rule of 3 is 3 edges per corner. That way I can adjust sharpness and arc. It takes at least 3 points to make an arc. That's where I start with arcs. So the corner of the eye, I would probably throw in 3, 1, 2, 3, and then the inside 1, 2, 3, right? So if you're kind of like, I don't know where to begin, sketch it out first. Right? Look for where you're going to put your stuff through an area, and also look how you're going to put it around. So if I was going to draw an edge loop for the eyelid line, I'm going to use an edge loop that goes all the way around the eyelid line. My next edge loop is going to go with the next visible shape change. I don't want to say next visible shape. I'm trying to say, I think I'd push it more towards the next substantial shape change, because the whole thing is rounded, so there's shape change everywhere. But I'm going to look for kind of landmark areas, and that's going to give me where things should go. And then I'm also going to try and pay attention to transitions, right? Reading the surface. Remember, that was one of those things I was telling you guys to work on in the beginning of the month, looking at a surface, trying to see how light transitions through, because you'll catch things like the way the brow transitions. He's got this big expression at brow. Might need something custom there, depending on how expression and I want to keep that. I'm also going to need to start thinking about how I'm going to transition from the center line, right? Center line out. I'll tell you right now, you don't want anything like, there are occasions that you may get away with doing these things in production scenarios, because in production it's more of, does it work, cool, ship it. But for most of the stuff, we don't want star junctions or any kind of funky topology down the center line. So I like to keep myself a border, right? At least a clean strip of polygons running through that. And this will start telling me how I'm going to transition my topology, making a star junction. Okay, and there might be things where I add one extra, so I can transition that star junction, but I'm changing direction. Now I've already built this guy, so I kind of have an idea of where my topology ends up going. But sketching topology, this is a lot easier to do than destroying your model, right? Just works a little better for me. All right, so now I take a screenshot of that and say, this is going to be where I'm going to start. I got a good idea. I've got a plan where I'm going to go. Let me screenshot that and then build it. Okay, so I'm going to go in there and start using the quad draw just to refresh your memories on a couple things with the quad draw. It is your tool of choice for this type of procedure. Please make sure that your high res has been locked down. It is made live. And then we can start quad drawing. So you could go the good old fashioned way and just quad draw your points. It's not really old fashioned. It's actually the way I like to do it. Maybe I'm just an old fashioned guy. All right, we can go in there, and sometimes it's a pain in the butt. And you hold your shift key. And if you hold shift and drag through, oh, that's the only part you got to watch out for with that. There we go. We can do something like that and drop that in. This takes a little bit more manual management as far as I'm managing my density as I go. So I can start really low, start figuring things out and gradually get higher resolution. Or another way that people like to start is, actually, let me go through them and keep that. I'll do it on the other eye. And if people are like, why aren't you using symmetry? Symmetry destroys your center line. So I'd rather just mirror it over when I'm done. I don't like to get into symmetry. But if you like to see on both sides, symmetry does work now. But what I can use is a quad strip. Okay, quad strips. I can drop in quads. Okay, this will evenly distribute a little bit better. Looks like something's a little different there. Again, this is my first time doing this with 2019, so I don't know if it's just because I went really fast or whatever. But how you work with this one is you can middle mouse and change the size, so you can pick your starting resolution. And we can say, all right, right here, click and drag. And I can go around the eye and situate. I like to keep the target weld on and then go from there. This takes a little bit more pushing and pulling because everything is a uniform polygon, right? So it kind of distributes everything evenly, and then you got to push it into shape. This way I can place things where I want them. I'm kind of a control freak, so I want that. And also your undos. God, it draws it out in one sweep, but then you have to undo it all manually. Okay. A little annoying. Okay, so I'm going to go in here and build the eye patch. Please be careful with going too light in the beginning, but also going too high in the beginning. It will hurt your ability to make some choices. I'm going to go in and drop in my edges that I will need. And then managing that. I'm going to try and maintain similar resolutions to the upper eyelid to the lower eyelid. If they're the exact same size, you should have pretty much the same number of edges going out of the upper eyelid as you do the lower. I'm also going to give this a little bit of thickness. Okay, so one of the things I like to use is, it's the tab key, but again, tab is quad strip, but if you're hovering, you'll get an extrude or an extend. It looks like they changed the name. I think it was called extend before, now it's extrude. So now I can extrude a loop on the fly in a direction, which is pretty cool. But in a lot of cases, what I'll do is if let's say that this geometry is going up that way because I want to establish the flow out of the eye, and then this geometry is going this way, but I want to extrude this out through the face. Hold tab. Awesome, I don't know what it did there. Come on. And it broke on me. There we go. Come on. Okay, I'm going to hold tab, right mouse, extend, but I can choose loop. I don't really use border. Border doesn't work as nicely as I would want it to. But I can start bringing out larger sections. This is how we can start picking up the pace. I must have turned off my auto weld. There we go. All right, so I can work in patches and whatnot as we go through. I'm always going to do maintenance, making sure things are flowing where they need to flow. Just going to put those together. Okay. So if you find that, you know what, I need to patch the forehead in, let me go ahead and build a big piece here. All right, I can go ahead and patch a forehead in there and then drop in my edges as needed and stitch it in. Sometimes that's a little bit of a faster workflow for some people. They like that. I'm going to go ahead and plant a star junction right there as we transition out of the forehead. Okay, another thing that's going to happen is as your geometry gets created, right, it's all erratic. Right? Using that erratic term, my edge flow gets a little erratic. Shift, smooth, or relax. If you want a larger influence area, so as you start packing your geometry a little bit more, hit the B key to get soft select up. Set your area, and now when you hold shift, it'll give you a much broader influence area, so you can kind of smooth out the cheek a little bit easier instead of trying to do with B key up. Remember that you're going to be hitting that on and off all the time, because that's the only time I use it is when I'm relaxing a large area. So as you get into the back of the head, side of the face, you're going to want to relax these large areas. soft select is definitely the way to go. But if I'm in an area like this, I'm just gonna shift and do it regular through there. Yes. Deleting stuff. So Control and Shift will get you into deleting faces, dots, edges. Control and Shift. Yep, that's your delete function. Now what I can do here is I'm going to bring this down and I'm going to stretch the geometry, but I'm going to keep an eye on that piece. I'm going to throw in an extra edge. I'm going to switch my extend back to extend edge. It's 2019. I thought you fix all this stuff on. There we go. It took the option, but just doing the radial for the mouth. Kind of just counting what's up on the upper lip to the lower lip. Now, a lot of people say, do I have to have, or they ask the question, do I need to have the mouth closed or should I do it open? Do it open. Even though the sculpture is not open, you're going to have to get in there a little close, bring your geometry in. I'm going to use Control to throw in an extra edge loop there. I'm going to kind of walk this, but I'm going to leave this open here. I'm going to leave the eyes open. I'm going to leave the nostrils open. This creates what we call a kill zone. You can terminate geometry inside that area without fear of it running through the rest of the topology. So if I need to add something down here, I can just add it to the lower lip. It's not going to go up into the upper lip. If I have something around the nose or in the eye, I can create just a kill zone in that area. And as I start to move geometry out and the density or the parameterization gets a little bit off, we throw in an extra edge and we can continue working through the asset. I'm going to go through here and hold Shift and smooth that out. Okay, this is how we go. All right, and that, you know, I'll show you next class. We'll look at some troubleshooting techniques and then we'll move into some other stuff. But again, you got your submission tonight. Yay, I know you're excited. If you guys need anything, let me know. Talk to Caleb, talk to Markson Lab, but get it done. And I'll see you on Wednesday. I will be, again, collecting files and grading tomorrow. So we'll go from there. And don't forget, 10 o'clock, the Fortress, bring all your how do I get in the industry questions, and I'll answer them, hopefully. All right, guys, have a good one. Online's been really quiet. There's actually nobody showed up today. Oh no. Bye, online.